Welcome to this explainer. Today, we're totally transforming how your AI coding assistant understands your code base. If you write code with AI, what we're about to cover is going to fundamentally change your workflow for the better. All right, let's dive right into what is arguably the biggest frustration in AI coding right now. You know the drill, right? You open your assistant, load up your files, ask a question, and get an answer. But then you start a new session, and bam, total amnesia. Your AI essentially has the memory of a goldfish. It's forced to reread your massive repository from scratch, just parsing raw data over and over. It's not just wildly inefficient, it is literally torching your token limits. So how do we fix this AI amnesia? Well, former Tesla AI director Andrej Karpathy hit the nail on the head when he proposed the concept of an LLM wiki. Basically, it's a persistent knowledge layer that actually evolves the more you use it, instead of booting up from zero every single time. And today, we're looking at how an open source tool called Graphify has stepped up to make this exact concept a reality. We've got a packed agenda today. We're covering vector RAG versus structural graphs, visualizing your God nodes, that massive 71.5x token reduction, commands for local analysis, token budgets and subgraphs, and finally, automating everything with Git hooks. All right, section 1, vector versus graphs, RAG versus structure. Let's talk about why the old way is broken. Standard vector RAG basically treats your beautiful codebase like a giant, messy bucket of words. It's just guessing connections based on semantic similarity, which means it completely misses the actual structural topology, how your code literally interacts. But structural graph intelligence, that's a total game changer. It uses deterministic extraction to map out the true functional relationships within your code, building a memory layer that actually persists. So, how does Graphify actually build this intelligence? It happens in two passes. Step 1 is deterministic abstract syntax tree, or AST, extraction. It uses a tool called TreeSitter to analyze your classes, functions, and imports entirely locally. Zero LLM needed, your code stays on your machine, and hey, it's completely free. Then, step 2 is parallel AI extraction. This is where Claude steps in. Claude analyzes your docs, PDFs, even images, extracting the deeper semantic meaning and design rationale, and merges it all into one unified graph. Moving right along to section 2, visualizing your God nodes and system architecture. Okay, you're gonna love this. Graphify identifies what we call God nodes. What are they? They are the highest degree, most hyper-connected hubs sitting at the absolute heart of your system's architecture. They're the foundational pillars that literally everything else relies on. Knowing exactly where these God nodes are is absolutely crucial because it tells you the blast radius of any code change you're about to make. And the output you get is this awesome interactive graph.html file. It's a fully clickable map of your repository. It actually uses the Leiden algorithm for community clustering based on true graph topology, so absolutely zero vector embeddings required here. It's amazing because it flags these unexpected cross-domain connections. You can literally navigate your God nodes and discover crazy architectural surprises without reading a single line of raw code. Let's jump into section 3, the 71.5x token reduction. Let's talk about saving those API costs. So get this. On a mixed benchmark corpus, we're talking Andrej Karpathy's repos, research papers, diagrams, the whole shebang. Graphify achieved a massive 71.5 times reduction in token usage compared to reading raw files. 71.5 times. And the why makes perfect sense. Asking an AI to navigate a structured map of relationships is infinitely cheaper and faster than forcing it to read the entire text library every single time you ask a question. It's a total no-brainer. All right, section 4, local commands. Let's get this running locally. First things first, let's get the package installed. It's super simple. Just pop open your terminal and run pip install Graphify. And yes, definitely make a mental note of that. It is Graphify with 2 Y's on PyPy. Once you've got it installed, the workflow is just seamless. Step 1, open up your AI assistant. Claude Code is absolutely perfect for this. Step 2, navigate over to your target repository folder. Step 3, just run the command /graphify ... and that is literally it. Graphify fires off its dual-pass extraction and, for step 4, drops a persistent graph.json file right into your local folder, alongside that interactive HTML map we talked about. Section 5, token budgets and subgraph control. Now, even with those massive token savings, you still want absolute control. Standard file reads, zero cost control. If your file is huge, well, you're paying for the whole thing. Querying the entire default graph structure is definitely better, but Graphify takes it to the next level. By passing a simple dash trash budget flag during a subgraph query, you dictate an absolute cap on tokens. You're literally telling the tool exactly how much context to extract, giving you absolutely flawless cost control. What's really cool is the level of transparency you get. The graph tags every relationship by its confidence level. If you see an extracted tag, that means it's an undeniable, cold hard fact parsed directly from your code's syntax tree. If it says inferred, well, the AI deduced it, and it even gives you a confidence score. And if it's tagged ambiguous, that means it's flagged for you, the human, to review. So you always know exactly how much to trust the insight.
Finally, Section 6, automating with Git hooks to perfectly sync your AI's memory.
Look, nobody wants to manually run terminal commands every single time they write a new line of code. So here's the ultimate developer flex. Just run Graphify hook install in your terminal. With that single command, you install a Git hook that puts your AI's memory updates completely on autopilot. Here's how that automated magic actually flows. Every single time you edit a file, make a local commit, or switch code branches, that post-commit Git hook fires off automatically in the background. Graphify instantly runs its Pass1 AST extraction, which again is completely free and completely local, and updates your structured graph. The result? Claude Code instantly knows about your new changes without you lifting a single finger. Your AI memory is perfectly, seamlessly synced. And to make this whole setup even more powerful, Graphify integrates flawlessly with MCP, the Model Context Protocol. Think of MCP as a universal USB port for your AI assistant. You just drop a simple .mcp.json file into your project's root directory, and boom, you've plugged this highly structured brain directly into Claude Code. You can even set it up to query across multiple different projects simultaneously, all from one single chat session. So we've seen how Graphify drags us out of the clunky, token-burning dark ages of vector RAG and right into the era of persistent, automated, structural graph intelligence. You've got the commands, you've got the Git hooks to slash your token costs by over 70 times, and you're handing your AI a perfect map of your code base. The only question left is your AI ready to finally remember? Thanks for joining me on this explainer, and I'll catch you in the next one.